Okay, so we are going to solve word problems using systems of linear equations, and we're going to decide the best method to use to solve these systems of equations. So we're going to go ahead and read the problem, and then we're going to kind of break it down a little bit so that it makes it a little bit easier to understand. So 1 month, Ryan rented 3 movies and 2 video games for a total of $18. The next month, he rented 5 videos and 6 video games for a total of $48. Find the rental cost for each movie and each video game. So it's kind of like a bundle. I know how much they cost together, but I don't know how much either movies or video games cost. I want to find the cost for each one. So the first thing you want to do is define your variables. So movies, I'm going to say are M, and video games, I'm going to say are games, or G for games. And we're going to write 2 equations for each situation. So 1 month he rented 3 movies and 2 video games. The next month he rented 5 videos and 6 video games. 5 movies and 6 video games. So 2 different situations. Then we're going to use multiplication to get opposites. So we're going to use elimination on this one. A lot of the time these ones work out to be elimination. That's usually the easiest method. It's not always. Sometimes substitution is an easier method. Then we're going to use elimination to solve. So I'm kind of already pointing you in the right direction here, but once we write the equations, hopefully you'll be able to see that elimination is the easier method. So if I look at the first situation, 3 movies, 2 video games, $18. So I'm writing it in a very simple sentence here. So 3 movies and 2 video games equals $18. So I've color-coded this on purpose so that it makes it easier when I switch this to algebraic version. So I have 3M for movies, 2G for video games, and equals $18. So here it is a little bit more scrunched together, so it's not so spaced out. So I have one equation. That's one situation. Now let's look at the second situation. We have 5 movies and 6 video games for a total of $48. So very similar sentence, but 5 movies, 6 games, $48. So now I'm going to do the same thing. 5M, 6G, and $48. So I've written the sentence. Now, again, I'm squishing it just so it's, a little easier to see without it being all spaced out. So now this is where you would actually make the decision, if you didn't have this little steps, the little notes guide on what what method am I going to use to solve this system. 3M and 5M, those cannot easily be turned into the other, but 2 and 6, 2 can easily be turned into 6, right? So that's my step. I know that 2 can easily be turned into 6. Nothing matches, and I don't necessarily know what one of the variables equals. So I'm not going to use elimination immediately, and I'm not going to use substitution. But if I use multiplication first and I multiply this first equation to get something matching, then I can use elimination. So it's just that process of, how do I get there? All right, so I'm going to multiply by -3 because I don't want +6 and +6, and I've talked about this in previous videos. If they're both positive or both negative, it means that I'm going to have to subtract one equation from the other, which is not necessarily bad. It's just a process to remember that you're subtracting each piece. If you have opposites, like -6 and +6, then I can add one equation to the other, and that makes it much easier. I don't have to worry about that subtraction sign. So -3 times 3M gives me -9M, -3 times 2G gives me -6G, and -3 times 18 gives me -54. Okay, so now here's the equation that I just manipulated a little bit. I'll move it over here so you can see it. And the second equation I'm just bringing up here. Now I have these 2 pieces matching, right? Except for the fact that they're opposites, which is exactly what I wanted. So now I can just add straight down. -9M plus 5M equals 4M. -6G plus 6G, well, anytime I have opposites, they're going to cancel. They become 0. -54 plus 48 is -6. Because they are opposites, I do subtract, and the bigger number decides my sign, or it helps me know what my sign will be. Not really deciding. Now I'm going to divide by -4 on both sides because I want to undo that multiplication. Don't forget to take the negative sign with this. If you leave the negative sign, if you just divided by 4, then you would have -M equals. Well, I don't want to know what -M equals. I want to know what just M equals. So -4 divided by -4 becomes 1. -6 divided by -4 becomes positive 1.5. So each movie cost Ryan $1.50 to rent. So now I have one of my answers. I need the other part of that. I want to know how much the video games cost. So I'm going to choose one of the two equations. I can choose the two original equations. I can choose this third one that I manipulated. Really doesn't matter which one I choose. I just have to choose one. So I'm going to choose this first one, the 3m plus 2g equals 18. Well, now I know how much movies cost. They cost $1.50 each. So if he rents 3 movies for $1.50, then he spent $4.50 on just movies. And now we're still adding the 2 games that he rented. We don't know how much the games are yet. We're figuring that out right now. And that equals $18. So I'm going to undo the $4.50. I'm going to subtract that from both sides so that I can get 2g by itself, because negative 4.5 minus 4.5, sorry, I said negative at the beginning. 4.5 minus 4.5 is 0. 2g drops down, and that equals 18 minus 4.5 is 13.5. So he spent $13.50 on just games. Okay, I'm going to undo that multiplication with division. So 2 divided by 2 is 1, and 13.5 divided by 2 is $6.75. So games are definitely more expensive than movies, wherever he's renting these from, quite a bit more expensive. So these are my two answers. Make sure that you go through and you answer both parts of the question. Don't just get to the end and go, oh, movies are $1.50 and I'm done. No, you have 2 parts. And on Alex, it's going to show you have 2 spots to fill in answers on. And this is by no means the only way to solve this question. This is just the method that I chose. All right, let's look at the next one. So a phone company offers 2 monthly plans. Plan A costs $11 plus an additional 12 cents for each minute of calls. Plan B costs $26 plus an additional 7 cents for each minute of calls. So for just a moment, we're going to take a step back in time here to when we did not have unlimited plans. So it definitely cost us money to talk on the phone. It wasn't just, here's your cell phone, talk as much as you want, send as many texts as you want, and it's unlimited. Nope. We had to pay attention to the minutes that we were using. Also, at different times of the day, it might cost more than, at the peak hours than in the evening or in the morning. So those were definitely things we had to pay attention to. But texting was also not free. Texting was 10 cents per text and 25 cents for, pictures or I'm assuming, the images now that we love to send, the memes, which were not available at the time. We made our own. So just a step back in time there. All right, so we're going to do the same thing. We're going to define our variables. So we have minutes for each plan, which we're going to go with M. That's really our only variable here. We just have 2 different plans. And we have a total cost for our plans, and we have our minutes used for each plan, which we're going to go with M. So we're going to write 2 equations again, one for each situation, and we want to find the number of minutes for the plans to be equal. That was our first question here that I haven't read quite yet. So for what amount of calling do the 2 plans cost the same? And then we can do that by setting the 2 expressions equal to each other once we set up these equations. So let's go ahead and kind of break them down. So the first plan, Plan A, costs $11 and 12 cents per minute. So we have $11 no matter what, and then for every minute that we talk, it's another 12 cents. And then for the second plan, we have $26 no matter what, that's our cost, and then 7 cents per minute. So here's 26 plus 7 cents per minute. So we have our 2 expressions, and we want to know when these 2 plans would be equal. For how many minutes do I have to talk for these 2 plans to be the same? And what this actually helps you do, if you figure out kind of the break-even point here, is not truly a break-even point, but the equal point, then you can decide on which plan is the best. Because if I'm going to talk less than this equal point, then the plan that costs less to begin with would probably be the better plan to go with. Even though it costs more per minute, I'm not going to be talking as much. But if I'm going to be talking a whole lot, and I'm going to use a lot of minutes, I may want to go with the higher plan. It starts higher, but it's a lot less per minute. So it all just depends on what I'm going to go with there. Okay, so let's go ahead and set the 2 equal to each other, because I want to know when will these 2 plans be the same amount. So now when I'm in the situation where I have a variable on both sides and a constant on both sides, I just pick something to start with. It doesn't necessarily matter which one I start with. So I always start with variables for a reason, and I try to go in a way that's going to give me a positive number. So I'm going to take this positive 7 cents from the right side, and I'm going to subtract it from both sides. So the 11 is going to drop down. 12 minus 7 is 5. And then the 26 is going to drop down. The 7 cents minus 7 cents per minute cancel out because anything minus itself is 0. So now I want to get m by itself. That's my goal at this point. So I'm going to subtract 11 from both sides. 11 minus 11 is 0. The 5 cents per minute drops down. Now I have equals 15. At this point, what I've actually done is I'm figuring out the differences in the two plans. So when I subtracted the cents per minute from each other, what I'm saying is there's a difference of 5 cents per minute from plan A to plan B. So there's a 5 cents increase from one to the other. And then when I subtracted the 11 from the 26, what I'm figuring out is what is the difference in that initial cost for each plan. So there's a $15 difference in that initial fee, right? Because to go from 11 to 26, that's a $15 difference. So really, I figured out the differences here. So now what I want to do is I want to undo that multiplication just like I have in the past here when we were solving problems. And when I divide any number by itself, it becomes 1. 15 divided by 5 cents is 300. So in order for the two plans to be equal to each other, plan A to equal plan B for cost, I have to talk for 300 minutes. Okay, so if I'm going to talk for less than 300 minutes, I probably want to go with plan A. If I'm going to talk for more than 300 minutes, I probably want to go with plan B so that, those minutes aren't continuing to add to my cost. They're 5 cents less for every minute that I talk on plan B. So again, it just kind of depends on what I need there. So the second question is, what is the cost when the two plans cost the same? So it's just saying at 300 minutes, what is my cost? What would I be paying for that bill? So we're going to choose either one of the two expressions here. So I'm choosing the first one, 11 plus 12 cents per minute, and I'm going to plug in 300 minutes here. I'm going to see, what do I get? So 12 cents times 300, it's $36. So that's how much I'm paying for my minutes. And then I also have to pay my $11 initial fee, which totals out to be $47. All right, so that's word problems using different methods for solving based on kind of given information there. I hope that helped, and I'll see you in the next video.